Bismillahirrahmanirrahim. In this topic, we are going to discuss how to graph the sine function. We know that sine function is one of the trigonometric functions. We have 6 trigonometric functions. They are sine, cosine, tangent, cotangent, secant, and cosecant. We'll start with the graphing with the sine function. And also we know that the sine function is related to the xy plane or fourth quadrant. We have fourth quadrant, 1, 2, 3, and 4. And based on this, we have quadrantal angles. And the quadrantal angles are 0. We define that quadrantal angles are to be the angle for which the terminal side is like on the one of the axis, either x-axis or y-axis. So the first quadrantal angle is 0. Then we have 90 or pi over 2 radian, 180 or 1 pi in radians, and 270 or 3 pi over 2. Then we go back to 0 again. So 0. And we say this is one cycle. We start with 0 and come back to 0, or which is equivalent to 2 pi. This is one cycle. Since the values of the trigonometric function repeated again and again, we go through this cycle or revolutions around one circle or like a wheel. We call this periodic functions. So the trigonometric functions are periodic functions. To clarify this, let's start with basic function. It's a graph. The function y equal to graph this function y equal to sine x. And I'm going to use the quadrantal angles 0, pi over 2, pi, 3 pi over 2, and 2 pi. And as we know, to graph any function, we are using points, and this will be the point for the variable x. This is x, and this is y, which is equal to sine x. First angle is 0, or first value for x is equal to 0. Second one is pi over 2. Third one is pi. Fourth one, 3 pi over 2 and 2 pi. Now, for the values of y, if x equal to 0, then sine of 0 equal to 0. So it is 0 and 0. Second one, sine pi over 2 is equal to 1. So when x equal to pi over 2, y equal to 1. Third one, sine of pi is equal to 0. We know that sine of pi is equal to 0. 3 pi, sine of 3 pi is equal to minus 1. And last one, sine 2 pi is equal to 0. These are the 5 points. Just to use it to graph the sine function for one period. We would say one period or one cycle. I start from 0, then pi over 2, pi, third point, fourth point is 3 pi over 2, and fifth point is 2 pi. It is like we just come back to the starting point. So we started this cycle from 0 and rotate to come back again. So this is one cycle or one period. Now the graph of the sine function will be start with 0. 0 gave me 0. Y is 0. If x equal to pi over 2, this is 1, it will be 1. If it is pi, I will have 0. If it is 3 pi over 2, it will be minus 1. This is 3 pi. It will be minus 1. And if it is 2 pi, I will have 0. So the graph will be start from 0, 0 to take this shape. To be more accurate. And it is a curve. It is not a straight line. This is not correct. We have a curve for the sine function. So this is the graph of the sine function from 0 to 2 pi. And we call this is one cycle or one period. If we move another cycle or if we get around this value again, I will have another values or another values for this one, and it will be copy paste from this graph. So this is one periodic or one period for the sine function from 0 to 2 pi. Now we have this height to the maximum point. We call it the amplitude. We have amplitude. We have the amplitude is just the distance or the height. Take the maximum value, that will be minus 1 to the 0. This is the amplitude, or between the minimum one or the absolute value of minimum 1 and 0. And we have, as we said, we have the period or cycle. Period start from the point 0 and 2 pi. This is one period. If I want to graph another period, it will be, I can take it in the other side. It will be exactly the same. So just copy paste from the first graph. So we can say in general, for the sine function, we have to define the period. We have to define the amplitude. So we can say in general, if we have sine function, this will be the basic properties. Graph of y sine x. It is periodic function. And the period starts from 0 to 2 pi. This is one cycle or one period. You can see. This is one cycle, or I can call it one period. Another period. See, this is another period. It is exactly the same shape of the first graph. This is another period. So this figure gives me 3 periods. So for the sine function, the domain will be all the real numbers. Domain is all the real numbers. Range, which is, that will give me the value of y. It is between -1 and 1. So for this function, y equal to sine x, the range is between -1 and 1. It means the minimum value will be -1. The maximum value is equal to 1. Again, I'm speaking about this function, because later on I'm going to multiply by some coefficient. Period is 2 pi. It is one cycle. Y equal to sine x. The period is equal to 2 pi. And this graph is symmetric with respect to the origin. The origin point, we see what is on the left will be symmetric to the graph on the right. And x-intercept all multiples of pi. It means it will be 0, 1 pi, 2 pi, 3 pi, 4 pi, and -1 pi, -2 pi, -3 pi. All of these will be the x-intercept for the sine function. So the x-intercept will be, or intercepts will be all multiples of pi. So in general, let's take the general case. It will be y equal to the function, the general form, y equal to a sine bx. This will be the general function for the sine function, or the general form of the sine function. Now for this one, we have number 1, amplitude will equal to the absolute value of a, the coefficient. Number 2, the period is 2 pi divided by b, or absolute value of b, can say. It is 2 pi divided by b, or I can say 2 pi. I'm sorry, absolute value of b. So now let's have one graph or one function, or example 2, graph this one. Example number 1. It's a graph y equal to sine x. How to graph this function? Y equal to 2 sine x. So number 1, the amplitude is equal to absolute value of the coefficient. The coefficient is equal to 2. So the amplitude for this one will give me 2. Number 2, the period. I'll use P for the period. Is equal to 2 pi divided by coefficient of x is equal to 1. So this is divided by 1 equal to 2 pi. So the period is equal to 2 pi. And sometimes we are finding something called the delta. Delta, it will be the period divided by 4. I'm going to use this one later on, so that when we have different periods than 2 pi, it will be easy to find the quadrantal angle. Now 2 pi divided by 4 is equal to pi over 2. I say this is the delta because I'm going to divide the period into 4 periods, or 4 sub-periods. Now to find the values for the sine function, or for this y equal to 2 sine x, I have x and we have y. Now for the values of x, I will use 5 points. First one is 0. Second one, I will write 1 delta. Third one, 2 delta. Then 3 delta, and 4 delta. Now when x, or when starting with the first point, it is 0. Now for 1 delta, we know that 1 delta is equal to pi over 2. So I'm going to write, or 1 delta is pi over 2. 2 delta. 2 delta, it is 2 multiplied by pi over 2. That will be 1 pi. So this the second one, or the third one, is 1 pi. So it is 0, pi over 2, and 1 pi. 3 delta. So multiply 3 by pi over 2. This is the third point, or the fourth one. And 4 delta, it is 4 multiplied by delta, which is pi over 2. That will give me 2 pi. So it is 2 pi. Now I need to find the values of y. Now if x equal to 0, see, we have y equal to sine of 0. Sine of 0 is equal to 0, so this is 0. Second one, we have y equal to 2 sine pi over 2. But we know that sine pi over 2 is equal to 1. 1 times 2, I will have 2. So it is 2. Third point, y equal to 2 sine of pi. But sine of pi is equal to 0. So 2 times 0 is equal to 0. Fourth one, y equal to 2 multiplied by sine 3 pi over 2. And sine pi over 2 is equal to minus 1. So minus 1 times 2 will give me minus 2. And the last one, when it is pi, I will have 0. Sine of pi is equal to 0 multiplied by 2 equal to 0. So we can see, for the sine function, the value of y for this form, y equal to 2 sine x, or a sine x, we'll start with y will be 0. The second one will be a, and a is equal to 2 in this example. Third one is 0. Fourth one is minus a, and fifth one is 0. So the values of y will be 0, then a is the coefficient of the function, then 0, then minus a, and 0. So the graph for this function y equal to, our function is y equal to 2 sine x. So again, I have, let me use, this is 2, 1, 2, this is 1, this is 2. Down, this is minus 1, this is minus 2. Point are 0, then I have pi over 2, then we have 1 pi, this is 1 delta, 2 delta, 3 pi over 2, and 2 pi. We have 0, 0, then we have 2, then 0 again, then we have minus 2. These are the points that we found in the table. I connect between these points, but these are not straight lines. We had a curve. So don't graph it in this shape. This is not correct. The graph of the sine is not straight line, it is a curve. So this is y equal to 2 sine x. And the amplitude equal to 2. the amplitude is absolute value of A, the coefficient of the sine or of the given function, then which is equal to 2. So this is how to find or how to graph sine function. Let's take another example. Number 2 or example number 3. Graph y equal sine 2x. I want to graph this sine 2x. So number 1, let's find the amplitude. Amplitude is equal to, it is absolute value of A, but we don't have coefficient term, means A is equal to 1. So this will be absolute value of 1, which is equal to 1. The coefficient is 1. Number 2, the period, and we said the period is 2 pi divided by B. In this example, B is the coefficient of x of the angle there inside. So B equal to 2, or absolute value of B. So it is 2 pi over 2. That will give me pi. Now the period is 1 pi. So the quadrangular angles are not a good choice for this one. They are not 0 or pi over 2 or 3 pi over 2 or 2 pi. Since the period is equal to 1 pi, I will find the delta, or I'm going to divide this period into 4 parts. It is 2 pi divided by 4. Why it is 4? Because we have 4 quadrants. This will give me the 4 quadrants. So it is 2 pi. So it is not 2 pi. In this example, I have B. And B is equal to 1 pi over 4. So delta is pi over 4, not pi over 2. It means I have to find this value of x and y. Start with 0. Then I have 1 delta. Then 2 times delta. Then 3 delta. And this one more, that will be 4 delta. The first one, 0. 1 delta means pi over 4. 2 delta, it is 2 times pi over 4. That will be pi over 2. So this is pi over 2. 3 delta, that will be 3 pi over 4. And 4 delta, that will give me 1 pi. So the last point will be the period itself. Start with 0, and the last one will give me the period. Now, if we choose the angle or the values for x in this way, then again, I will have, so for the values of y, these are 0, a, 0, minus a, and 0. So it means I will have 0, a is equal to 1, then again 0, then minus 1 and 0. This will give me the points or the values of y if we choose x to be 0, pi over 4, pi over 2, and 3 pi, and 1 pi. So the graph of this function now for 1 period. We are graphing this for 1 period. The points are 0. Second one was 1 delta, which is pi over 4. Third one is 2 delta, which is pi over 2. Third one is 3 pi over 4. And the last one is 1 pi. So the period is 1 pi. And the amplitude between 1 and minus 1. So the first one 0, 0. Second one is 1. Third one is minus 1. Then 0 and there's a mistake in this point. And this is pi, or 3 pi. This is pi over 2, yes, correct. Go back to see. Yes, 3 pi over 4. This is 3 pi over 4, and it is 1 pi. So this is correct point. And the point R will be 0. I said it is negative. This is 0, 0, 1. Then 0, we have minus 1 and 0. So the graph is, this one, take this out. So this is the graph of the function y equal to sine of 2x. You can see the period is 1 pi. Amplitude is 1. And this point for x will be pi over 4, pi over 2, 3 pi over 4, and 1 pi. So this is one period. If the question say graph for another period, we can go for another period, the other side or maybe to the right. But what we are doing now is one period that will be between 0 and 1 pi. So this is the graph of y equal to sine 2x. 2x, the period is only 1 pi.